Okay, so with investigation 4, we're going to start off by looking at our vocabulary. The vocabulary is going to be a lot of words dealing with weathering and erosion. That's our topic for in this investigation. So we can see we have abrasion, chemical weathering, erosion, frost wedging, hydrolysis, landslides, mass movement, mechanical weathering or physical weathering, matrix, mud flows, oxidation, and weathering. And they have here a little note that sediment that settles in water forms horizontal, distinct layers. And that's going to be separate from other layers that form. So they will be very, very noticeable. One of the first labs that we went through with this was our stream table lab, and with our stream table lab we had a worksheet that went along with that to answer some of the different questions. Here's what that worksheet looks like. We're going to be looking at some things with where the eroded material is going, what are some of the larger particles being deposited and the smaller particles. We're going to be looking at the delta, where's the water flowing the fastest and the slowest. What's the color of the water flowing out of the stream table? Okay, things like, watching the grains move, and then considering where the eroded material is going, looking at a map of the United States, and then what came first. So obviously we'll be able to go through all these different parts by watching the time lapse. So this is going to go fast. We're going to do this whole thing in about 30 seconds. We had a lake forming here, and we can see that the river kind of cuts down. It spills over. So this is a look at what we call the spillover theory for the Grand Canyon. And with this spillover theory, we see how the lake that formed back here eventually overflowed, spilled over, and we got to the river that formed at the end. So we'll loop this through and we'll play it one more time so we can kind of explain a little bit more of what's going on and some of the different landforms. So we see the lake forming here. We could see the deltas forming down in here. Okay, we could see how the eroded material is being moved as it's being carried and deposited further down. You can see that the eroded material is moving the fastest where the greatest change in elevation is. Okay. As we talk about this, we can use this stream table not only for the formation of the Grand Canyon, but for any instance where we're talking about weathering and erosion and materials being broken down by water. So as we look here at a different angle of this stream table, we can kind of see how it starts to spill over. Each time we recreate this, it does form in a slightly different path. But you can see with the eroded materials, it's definitely moving a lot faster where the eroded materials are going through the greatest change in elevation. We had a little bit of rainfall with a little bit of a mist there to kind of represent what happens in nature, and we get some additional flooding taking place. Granted, this is sped up quite a bit from what we would normally look at. You could see with the dye, it moves the fastest where the greatest change in elevation is. We still have our lake forming back here. Even though this is taking a different shape than the time lapse, we can see a lot of these different formations taking place. We can see down here we have kind of valleys forming, definitely canyon V's, the plateau back up here. So when we talk about what came first, we had to have our Colorado Plateau first, and then we had to change that and go into what would be the Colorado River spilling over the surface of this, and then finally going into our Grand Canyon, where the river would cut through the plateau and make our canyon. You could see on a scale model how we have the canyon walls forming here, and how that erosion and weathering is taking place and making changes to what we see. And we can see in this last angle, again, not too much different than the previous angle, but you get a look at the erosion that takes place right in the beginning. We get this waterfall, and that waterfall is going to keep working its way, cutting its way back up to where the mouth of the river kind of comes through. So we have our Colorado Rocky Mountains represented in the end here by the bottle, coming through the different states, eventually working its way into Arizona and through the Grand Canyon. and eventually then working its way to the Pacific Ocean. Now, since we've put dams on the Colorado River, most of the sediment and debris from the Grand Canyon is going to get built up into the Hoover Dam and Lake Mead. But before the creation of the Hoover Dam, a lot of that sediment and material would make it further down the river into California and then possibly even into the Pacific Ocean, which would be the ending point of the Colorado River. So you can see how that sediment and debris is being carried down, kind of starting, stopping, bouncing, zigzagging. Okay, and you can see the different formations taking shape with this as well. We can point out floodplains and landforms of all different types. Okay, I also passed out this sheet in class to kind of show some of the different landforms that we would see with that Grand Canyon. We are going to have to take a look at some of these different landforms for the test. Okay, as we see, we have the mountains and the canyons and the plateau. Valleys start to form similar to like we were in. We see the river meandering back and forth. Okay, and all the vocab words for these different terms are right here. So we see floodplains, regular plain, beach, the delta, which we talked about before. We could see forming that kind of fan-shaped deposit of sediment at the mouth or end of the river. So we went over a couple of those different things as well when we looked at our stream table models with the class. Some of the other things that we did was we read the article on the Grand Canyon flood. Okay, and they give us a whole bunch of different things with that. We can kind of see with the first question in there, if you were to flood out the Grand Canyon area, what would you focus on? And they give us a whole different bunch of things where you can look at the speed of the river and how it changes, the height of the river, the strength of the water in the river, the ecology or fish life in the river. Okay, some of the other things we're comparing the Grand Canyon article where the flooding took place to our stream tables, and they go over some of the similarities and differences. I mean, on a model scale, our stream table does a pretty good job of representing what the Grand Canyon did, and in its formation from about 5.5 million years ago, 6 million years ago to today. Okay, and with the last one, we kind of looked at some pictures in the book, and you could see with the flooding that it changed the coastlines of some of the areas and deposited a little bit more sediment and debris in a couple places. We also watched a short video on weathering and erosion. We had the worksheet that went along with that. So we answered these questions and went over them in class dealing with the video. So we could see some of the different things that we kind of talked about. Examples, a lot of this goes right back to what we looked at with the vocabulary words. Okay. Talking about weathering and erosion and the different types of weathering and erosion. Okay. Then we had these 3 questions here that we're doing for homework. Wind blown across bare soil moves earth materials. What size particles do you think wind would carry further? And which ones would get deposited first? So, kind of common sense fits in here where the smallest, lightest particles are going to be carried farther, and the larger, heavier particles are going to get deposited first. With question 15, explain the steps involved in breaking down mountain rocks and depositing the sand, silt, and clay in different places hundreds of miles away. Okay, well, we're going to talk about weathering, where water and ice and animals and chemical breakdown of rocks are going to get them into small pieces, like sand, silt, and clay. Wind or water is going to carry these different pieces from their original place, and they're going to deposit them in places far, far away. The larger pieces are going to get deposited first, and the smaller, lighter pieces are going to get deposited further away. And then we look at another question here about the Grand Canyon. It's taken the Colorado River about 5 years to erode through the Grand Canyon from a flat Colorado plateau. The Grand Canyon is about 4,500 feet deep at the south rim, Grand Canyon Village. If you could visit the Grand Canyon about 1 million years from now, what changes would you expect to see? And when we look at that one, we're going to say that the Grand Canyon is going to keep growing and getting larger. So we expect to see more erosion that's taken place and weathering. So the Grand Canyon sides would probably be wider and deeper. It's also going to start to get more of a a U-shaped and a little less V-shaped as it starts to widen out, but we definitely expect it to get deeper and wider. Okay, we went through a PowerPoint as well with the class on weathering and erosion. We started off kind of tying it back again with the Grand Canyon because it's a really easy example to use on how weathering and erosion takes place, and when we're talking about sedimentary rocks, how they build up. Okay, so we look at the Grand Canyon forming, like we said, more than 5 million years ago as the Colorado River cut its way and carved its way through the Grand Canyon. Okay, weathering is the process where rocks broke down into smaller and smaller pieces. There's no movement with weathering. That's just the breaking down of rocks. And they're giving us here an example of frost wedging. That's probably the main way in which rocks are going to get broken down. So even going back to those questions in the video review, I believe it was question 3, and it asked what's the most frequent cause of rocks breaking apart. And we talked about frost wedging and the constant cycle of freezing and thawing. So that's a big one to make sure we know. Okay, weathered or weathering is when something's been broken down due to usually physical processes, but sometimes also chemical processes, but it's the breaking down of rock. Okay, we use the Sphinx as an example. We kind of talked about how it really wasn't Napoleon firing cannons at the Sphinx that caused the nose to fall off, that it was most likely weathering that just wore away at the Sphinx. And there's another example there, and we can even see the weathering that's taking place in the background on one of the Great Pyramids as well. So you can see the different weathering that's taken place. Clearly, no effects of a cannon being fired at all these different objects. So that's where we're going to look at weathering for that. So we look at physical weathering or mechanical weathering, where the rocks are being broken apart, but not actually changing. So those little grains of sand that come off the rocks are exactly the same as the rock they came from. Okay, they haven't changed their composition in any way. And usually this happens from wind, running water, plant roots, frost wedging, just to name a few examples. Chemical weathering are chemical reactions which occur between the minerals and the rocks in the environment. So we were looking at how plants would secrete mild acids and different ways to break down the rock. Water is the main cause of chemical weathering. It contains weak acids that can be broken down. So every time it rains, it's essentially acid rain. We get a lot of carbonic acid from the rain in very, very mild doses, and over enough time that can eat away at the rocks. Oxidation is another example. When oxygen joins with a new substance, we call them oxides. Rocks can go through a lot of oxidation, which will weaken them. That's an example of chemical weathering. So we have the Gansu China here, where we can see the different colors brought to life here by oxidation. When we look through this picture, which is probably one of the best examples of oxidation, you can see all the different colors as it's wearing away at the mountainside. Okay, we can look at the Statue of Liberty. Okay, with the Statue of Liberty here, the copper starts to oxidize to a teal color. Okay, it started off originally like the copper pipes probably in your house carrying the water, and if you notice anywhere where there's drips of water that get on the copper and it oxidizes, it does turn to green in some spots, that copper pipe. Then we're going to get into erosion and some of the different types of erosion. Okay, with wind erosion, lighter objects such as pebbles and sand are carried away by the wind. Wind erosion plays a large role in deserts where there's a lot of sand, and the wind's going to be picking up a lot of the tiny pieces of sand to create that. So when we talk about desert types of sand, they're generally very, very small. Water erosion, we look back at the Grand Canyon. It's probably our best example of that and easiest example of that to see, where we can look at rocks and pebbles and boulders being carried downriver, and as they smack into and hit off of the riverbed, they keep causing more weathering and breaking down of the rock. Glacial erosion, giant bodies of ice can pick up houses as big as a house and can make rough surfaces smooth. the ice has tremendous power to change the shape of the surface of the Earth. It just doesn't happen all the time. But when the glaciers do come through, they can have a lot of force and a lot of an effect on an area.